Hi, welcome to Mrs. Park's Geometry class. This is Chapter 2, Section 3, Conditional Statements. Okay, why? So call centers routes calls to the appropriate departments using menus that allow callers to choose from a number of options. The recorded directions are frequently in the form of conditional statements. So when you call and you hear like automated voice, it says something like, if you would like to speak to a representative, press 0 now. If you'd like to speak, if you'd like to listen to it in English, press 1, and they have all these options. So that is a conditional statement. When they tell you, if you want this, then do that, that's a conditional statement. So if-then statements. A conditional statement is a statement that can be written in if-then form. The direction given above is an example of a conditional statement. If you would like to speak to a representative, then you will press 0 now. So here's the key concept given to you in a chart here. So conditional statement and if-then statement is of the form if P, then Q. And the symbol here, you have P and an arrow pointing to Q. So you read this as P, if P, then Q, or P implies Q. The hypothesis of a conditional statement is the phrase immediately following the word if. So if, after the word if, the P part is the hypothesis, the then part is the conclusion. So Q, the conclusion of a conditional statement is the phrase immediately following the word then. Okay? So if P, then Q. Here's a model. If it is P, then it is Q because it's inside the P. When a conditional statement is written as an if-then statement, you can quickly identify its hypothesis and conclusion. So identifying the hypothesis and conclusion. Identify the hypothesis and conclusion of each conditional statement. If the forecast is rain, then I will take an umbrella. So mind you, the if and then is not included in the hypothesis. The hypothesis is what comes after. The forecast is rain. Conclusion, what's after then? I will take an umbrella. Okay, so make sure you do not include the words if and then inside the hypothesis and conclusion. Okay, B. A number is divisible by 10 if its last zero is a 0. So this one they switched it. So what's the if part? What's the condition part? The hypothesis is the last digit is a 0. Okay? So if its last digit is 0, then a number is divisible by 10. Okay? So if part is the hypothesis, the last digit of a number is 0. Conclusion, the number is divisible by 10. Okay? Oops. Let's try to click on the next one here. There we go. Alright, so here's your turn, number 1A and B. Identify the hypothesis and conclusion of each conditional statement. So go ahead and pause the video and write that down for 1A, 1B, and come back when you're done. Alright, welcome back. Many conditional statements are written without using the words if and then. To write these statements in if and then form, identify the hypothesis and conclusion. Points will be deducted from any paper turned in after Wednesday's deadline. So the if part is paper turned in, if it is turned in after Wednesday's deadline. The then part, the conclusion is points will be deducted. So if you want to write it in if-then form, if a paper is turned in after Wednesday's deadline, then points will be deducted. Remember, the conclusion depends upon the hypothesis. Okay. Example 2. Write a conditional in if-then form. Identify the hypothesis and conclusion for each conditional statement. Then write the statement in if-then form. Okay. A mammal is a warm-blooded animal. The hypothesis is an animal is a mammal. Okay. Conclusion, it is a warm-blooded. If an animal is a mammal, then it is warm-blooded. Okay. B. A prism with bases that are regular polygons is a regular prism. The hypothesis part is a prism has bases that are regular polygons. Conclusion, it's a regular prism. So if you write it in if-then form, If a prism has bases that are regular polygons, then it is a regular prism. Okay, so here's your example 2A and 2B. Identify the hypothesis and conclusion for each conditional statement. Then write the statement in if-then form. So each of these problems, you need to tell me what's the hypothesis. So when you write your answers, you can put 2A. Okay. Hypothesis, you can just put H for hypothesis. Write this hypothesis. C for conclusion. And then write your if-then form. Okay, so you should have 3 answers here. Okay, good. The hypothesis and conclusion of a conditional statement can be a truth value of true or false, as can the conditional statement itself. Consider the following condition. If Tom finishes his homework, then he will clean his room. Okay, so hypothesis is Tom finishes his homework. Conclusion, Tom cleans his room. Okay, so if the hypothesis is true and the conclusion is true, then the conditional statement, if Tom does finish his homework and he does clean his room, then the conditional statement is true. If one of them is true and the other is false, then it will be false. If Tom does not clean his room after he does his homework and he has not fulfilled his promise, and the condition is false. If he finishes his homework and this is false, and Tom cleans his room is true, the conditional only indicates that will happen if Tom does finish his homework. He could clean his room or not clean his room if he does not finish his homework. So we don't know what happens if he does not finish his homework. He might clean his room, he might not clean his room. When the hypothesis of a conditional is not met, the truth of a conditional cannot be determined. When the truth of a conditional statement cannot be determined, it is considered true by default. So if we cannot determine it, cannot be determined, then it's going to be true. Okay? So reading math, not false. If a statement is not false, logic dictates that it must be true. If it's not false, then it is true. Okay. The results from the previous page can be used to create a truth table for conditional statements. So we've done truth tables in the previous section. Notice that a conditional is false only when its hypothesis is true and its conclusion is false. So let's read that again. Notice that conditional is false only when its hypothesis is true and conditional is false. So you can only be false if the condition is true, the hypothesis is true, but the condition is false. Okay. The only in this case will be false. Notice too that when a hypothesis is fake, the conditional will always be considered true regardless of whether the condition is true or false. So if the hypothesis is fake, then it's going to be true. To show that conditional is true, you must show that for each case when the hypothesis is true, the conditional is also true. To show that a conditional is false, you need only to find one counterexample. Okay. Determine the truth values of each conditional statement. If true, explain your reasoning. If false, give a counterexample. A counterexample is an example that proves it false. If you divide an integer by another integer, the result is also an integer. So a counterexample, is something that makes it false, that proves it false. When you divide 1 by 2, the result is 0.5. So if you divide an integer by another integer, it is also an integer. No, it's not. It's 0.5. That's not an integer. So that is one example. That's a counterexample to make the conditional statement false. All right. So this is false because we found a counterexample. Okay. If next month is August, then this month is July. If the hypothesis is true, the condition is also true. Since August is the month that follows July, so the conditional statement is true. So this one's a truth. Okay. If a triangle has 4 sides, then it is a concave. Okay. That's false. Since the triangle can never have 4 sides. Okay. But, okay, so this is, okay, never mind. Let me erase that part. So a triangle has four, if a triangle has four sides, then it is a concave. Alright, so this is where it's going to get tricky, because you know this is false. A triangle can never have four sides. A conditional with a false hypothesis is always true. So this is going to be a true statement because the hypothesis is false. Okay, so when the hypothesis is false, it's going to be always true. Okay, so here's your turn 3A through 3B. Okay, same thing, determine the truth value. If true, give a reason. If false, give a counter example. So go ahead, do number 3A and 3B, and come back when you're done. Okay, welcome back. Related conditionals. There are other statements that are based on a given conditional statement. These are known as related conditionals. Alright, so this is A, if P, then Q. Okay. Examples, if measurement angle A is 35, then measurement or angle A is an acute angle. A converse is a form by exchanging the hypothesis and conclusion of the conditional. That means they're switching it around. So now P becomes the condition, and Q becomes the condition, and P becomes the conclusion. So here, conclusion. So this is switched around. So now, if angle A is an acute angle, then measurement angle A is 35. Okay, so they're switching it around. Inverse is negating both. So here's the original, right? So instead of P, then Q, we're going to say not P, then not Q. Okay, that's the inverse. If measurement angle A is not 35 degrees, then measurement angle A is not an acute angle. Okay. Contrapositive is when you do both. So now you switch it around. You put the P first and you put the Q later, and then you're doing not, negating not and not. So if not P, then not Q. If angle A is not an acute angle, then measurement angle A is not 35 degrees. Okay. Oops. So, a conditional and its contrapositive are either both true or both false. Similarly, the converse and inverse of a conditional are either both true or both false. Statements with the same truth values are said to be logically equivalent. A conditional and its contrapositive are logically equivalent. Okay. The converse and inverse of a condition are logically equivalent. Okay. If a conditional is true, the converse may or may not be true. Okay. So here's a real-world example for nature. Write the converse, inverse, and contrapositive of the following true statement. Then use the information at the left to determine whether each related conditional is true or false. If a statement is false, give a counterexample. So here is your statement. Lions are cats that can roar. Okay, there's your statement. So if you write an if-then form, if an animal is a lion, then it is a cat that can roar. Okay. So this is the P part, and this is the Q part. Okay. A converse, remember you're switching it. P and Q are switched. So if it is an animal that can roar, then it is a lion. That is false because there's a counterexample. A tiger is a cat that can roar, but it is not a lion. So tiger is our example, a counterexample, so it is false. Alright, inverse. So inverse, you're negating it. If an animal is not a lion, then it is not a cat that can roar. Is there a counterexample? A tiger is not a lion, but it is a cat that can roar. So a tiger is another counterexample. Therefore, this is false. Converse is false, inverse is false. Contrapositive. Okay, we're doing both now. Not Q and not P. So if it is not an animal that can, if an animal is not a cat that can roar, then it is not a lion. Based on the information at the left, the statement is true. If an animal is not a cat that can roar, then it is not a lion. So this is true. Okay. So if you want to look at the previous slide, both conditional and contrapositive are true. Yes, check. Both the converse and inverse are false. Then check. Then you did it right. So here's your example, your turn number 4A through B. Okay, do the same thing what we did in the previous slide. So you need to do both converse, inverse, contrapositive, and a true conditional statement. Tell me if they're true or false for each one. And if they're false, find a counterexample. Okay, so write this down, and when you're done with homework. So make sure you put it in your book bag for credit, and thanks for watching.